We're going to spend a couple of days in section 1.9. So let's start out by defining a few things. I'm going to use the phrase parent functions, quite a bit. And that's the simplest function with the defining characteristics of the family. So I have two children, and if I were to ask you to pick out my two children from this list, you would probably look at it and say, well, probably Danae Williams and probably Scott Williams. And you would choose those because of their last name. So just like people, functions have identifying characteristics that group them in a family. So just think of the parent function as the last name of the family. It's how you identify the function. So I want to give you a hint here. Parent functions do not have the operations addition, subtraction, multiplication, or division. They only have the last name. So if we go down here and we scribble off anything that has to do with adding, subtracting, dividing, and we don't cross off the exponents because that gives the function its family. So if we look here now, we're going to just circle any variables that are identical to the same power. So we have this one is x, this one is x, this one is x. So we're going to circle this one, this one, and this one. These are all in the same family. Now they have transformations done to them that we've crossed off. We've multiplied, subtracted, divided, but they all belong to the same family. Just like in your family, you have characteristics that are similar with your siblings, but you also have some differences. Now, you are going to have to memorize these 3 rows of that table. Let me just wait this out here so you can see which one's a little bit better. So I want you to memorize these 3 rows. You need to memorize the family name, you need to memorize the rule, and you need to memorize the graph. Now, with the constant function, it's a little bit different than these linear, quadratic, and cubic and square roots because the constant function depends on what value we put in for c. So just for the graph, we could have it at 0 here, but you really won't be able to see it. We're going to put it right up here. It's a horizontal line, and it has a constant rate of change. So when we talk about this, if we want to talk about the domain and range, this goes on forever in the negative direction and in the positive direction. So that means that x is all real numbers. Now y is going to be whatever c is, because this is going to, every single point on here is going to have the same y coordinate. So that's going to be c, and this is going to intersect the y-axis at c. Now I'm not going to ask you to memorize these last 3. You should be able to figure them out, but these are what your quiz is going to be over. But I do want you to understand the domain and range for all of these. Now linear, you can see the word line in here. Linear function is just f of x equals x. And we could look at this and know that it has a slope of 1 and it intersects the y-axis at 0 because there's nothing here. So we're going to just put a point here because all of these parent functions are going to go through the origin. So again, this one has a slope of 1. Connect our points, we have our line. This goes on forever. So the domain is all real numbers and also the range because it goes up also. Intersects the y-axis at 0, 0. The next one is the quadratic function. I'm going to give you some little tips to help you remember these. If you look at the second letter in quadratic, it's a U. So, oops, I kind of messed that up there. The quadratic function is a parabola. So, and it is f of x equals x squared. And we're going to go through the origin. So that means this keeps on going. It's going to go out along the x-axis, so it's going to be all real numbers. And then here, we don't have any y values for the range that are less than 0, so we want to say that y is greater than or equal to 0. And again, this function is going through the origin at 0, 0. The next one is cubic, so just think what power a cube is. If you would cube something, you would put an exponent of 3 on it. Now this one is going to start low, and it's going to kind of bend as it goes through the origin, and then come back up again. So for this one, don't make this one, get a slip of paper here. Well, let me just write it here. Don't make this one like this, because that's going to be a transformed cubic function. You want to make sure it's kind of steep right here, going down, bends at the origin, and then gets steep again. Now, because this one keeps on going forever in this direction and forever in this direction, the domain is going to be all real numbers, the range is going to be all real numbers, and we already know that it goes through the origin at 0, 0. Okay, the square root function. F of x equals, is as easy as this, the square root of x. Now, I usually tell students that to memorize the shape of the square root function, just think of what the square root looks like. And basically what you're going to do, I'm going to write it over here, is you're going to take off this little tail here, and you're going to kind of curve it here and make it kind of go up like this. So our square root function is going to start here and go like that. So if you can see here, when we talk about the domain, we don't have any negative values. So x is going to be greater than or equal to 0. And we don't have any negative values for y either. So y is going to be greater than or equal to 0. Now, just as a person's name is an indication of the family they belong to, each exponent, let me write last in here. Each exponent or radical sign, so for our case, the square root sign, indicates the family the function belongs to. Okay, that's it for section 19A.